Hi, hello and welcome everyone. We are happy that we are all together again. In this class, we will start to learn about the performance units. So what are these performance units? Well, when it comes to HVAC equipments, we have some ratings available in the market. It could be American standard or else international standard or else European standards. So these ratings are being useful in order to compare the equipments and also decide the equipments for the lead certification. So let's see about this little broadly. First we have coefficient of performance, which is COP. Coefficient of performance is a measure of the efficiency of your air conditioning compressor. A COP of 4 means that the air cooling energy from the air conditioner will be 4 times more than the input energy. So for 1 kilowatt input power, you get 4 kilowatt of cooling power. This is the definition of the coefficient of performance. We have one formula in order to calculate the COP of any equipment, as in it could be the cooling equipment or else any other refrigeration equipment. Heat output from the condenser in kilowatt divided by power supply to the compressor. So this is a formula in order to calculate the COP value of any equipment. What is the use of this COP? Well, coefficient of performance is the equivalent measure using SI units, which is widely used in the UK. A COP of 1.0 equates to an EER, which is energy efficient ratio of 3.4. So what are the equipments using this rating? We have heat pumps, air conditioners and refrigeration equipments. So almost all kind of HVAC equipments are using this rating. EER, energy efficiency ratio. It measures the cooling energy generated in BTU per hour and divides it by the input electrical power measured in watts. Typical values range between 10 to 12. So the formula for COP, this is not COP, this is energy efficient ratio, EER. Okay, simply change that one. EER equal to AC capacity in BTU per hour divided by power input, which is in watts. So you can get these values from the manufacturer catalog and you can just calculate the EER. Most of the cases in the manufacturer data sheets itself, they would mention the EER rating of an equipment. So what are the equipments are using this EER rating? Well, we have heat pumps, air conditioners and refrigeration equipment which are using this EER rating. COP and EER, those are the ratings are traditionally being used in the HVAC industry. Since the industry is evolving, we have some other ratings as well, which we are going to see now. The next one is seasonal energy efficient ratio. This describes how much cooling the unit delivers for each watt of electricity. Efficiency is expressed as the seasonal energy efficiency rating or SEER. What are the equipments are using this standard? We have heat pumps and air conditioners. The minimum SEER for a split system central air conditioner allowed today is 14. So look for the units with SEER rating of 15 or greater. The higher the SEER, the more you can lower your energy cost. So please try to go with the SEER rating of 15 or else the greater than 15. You can save plenty of costs from the very high rated SEER rated equipment. IEER, integrated energy efficient ratio. This value is more representative of the actual efficiency you will get out of your HVAC equipment. To calculate this, efficiencies are reported at different loads. Outdoor temperature ranging from 65 to 95 degrees Fahrenheit, and then given weights to obtain an overall efficiency value. Surprisingly, the peak load efficiency only count for 2% of the overall value. As you can see, we have one formula in order to estimate the IEER value. IEER is calculated as follows. IEER is 0.02 multiply A plus 0.617 multiply B plus 0.238 multiply by C plus 0.125 multiply by D. This is the overall formula for IEER rating, whereas A is equivalent to EER at 100% net capacity at AHRA standard condition at 95 degree Fahrenheit. Well, B is equivalent to EER at 75% net capacity and reduced ambient temperature, as in 81.5 degree Fahrenheit. It's an EER rating for 100% load and 75% load. Okay, and also you can see the temperature is also being changed from 95 to 81 at the B level, and during the C level we have EER at 50% net capacity and reduced ambient temperature, which is equivalent to 68 degree Fahrenheit. And when it comes to D, we have EER at 25% net capacity and reduced ambient temperature, which is equivalent to 65 degree Fahrenheit. The A, B, C and D value can be obtained from your manufacturer data sheet, and once you apply those values in this formula, you can simply find out the IEER rating of the equipment. Mostly, IEER rating will be available in your manufacturer data sheets as well. The next one is IPLV, or else integrated part load value. More geared towards chillers, but still calculated the same way and gives a standard for real world efficiency comparison. The formula from AHR is below. IPL is equivalent to 0.01 into A plus 0.042 into B plus 0.45 into C plus 0.1 into D. As you could see in the IEER rating, the formula are almost same, but the only difference is that EER rating shall be considerable when it comes to IEER rating. But in here, we will be considering the COP or else EER rating. Okay, so these two can be considered, and also as you can see, there are part load values also we are considering. And once you apply this rating in this formula, you will get your IPLV value. Okay, mostly we are using the IPLV value for the chillers. Okay, so totally this kind of ratings are currently in market, and depends on your equipment, you can choose your rating method, and also these rating methods will be very helpful when you compare when you work on any LEED certified project. Definitely the consultant will ask you for go with the very high IPLV rated chillers or else very high COP or else EER rated air conditioner. So better the rating, the better efficiency you will get. As a result, you will get good LEED rating as well. So this is the end of this class. I hope you understand something about the equipment ratings when it comes to HVAC industry. Let's see you in another class.